Hi guys, welcome to Algebra 1. As you can see here, there's going to be 4 lessons within this playlist of Algebra 1, and this is lesson 1, Introducing Algebra and Simplifying Like Terms. Okay, so let's get started. Okay, so start with very easy. Let's spot the odd one out. Very, very easy. Lots of football players there with balls, and there's a little ballerina here, so this is obviously the odd one out. What I'm really trying to show you here are these are all like each other. And we're going to be using the word like terms further on when we talk about algebra. These are all like each other. This is not, so this is the odd one out. Again, spot the odd one out here. So if I move this guy over here, and I move these guys up here, you can see that all of these here are like each other. All of these here are like each other. So this one here is obviously the odd one out. Okay, again, there's apples, bananas, oranges, and strawberries here. If you had to group them together, what would they look like? And they would look like this. So we've got 2 apples, we've got 6 strawberries, we've got 4 oranges, and we've got 5 bananas. So just to make things a little bit simpler, you can see here that I've made apples equal A, I've made strawberries equal S, I've made the oranges equal O, and I have made bananas equal B. So I'm just going to start writing a little bit here. So the bananas are A plus A. So how can I simplify that? If I had A plus another A, what would I have all together? And I would have 2 lots of A, so 2A. Here, I've got 1, 2, 3, 4, 5, 6 strawberries. So again, you could write it like 1, 2, 3, 4, 5, 6. So S plus S plus S plus S plus S plus S, what does that give you all together? And it gives you 6S. The oranges, 1, 2, 3, 4. How could I write that? So O plus another O, plus another O, plus another O equals what? 4 O's. And bananas, very similarly, 1, 2, 3, 4, 5. So you could just go straight to 5B. Okay? What would I have all together? How could I write that all together? So it would be like 2A plus 6S plus 4O plus 5B. Okay? And we explain in the next slide. These are like terms. The B's are like each other. The O's are like each other. The S's are like each other. And the A's are like each other. Because they are like terms, they cannot add or subtract with other like terms. So that is the simplest answer you can get. So let's move on to the next slide. So here, again, collecting like terms. So again, this is from the last slide. I've got 2A plus 6S plus 4O plus 5B. This here is called an algebraic expression, and each of the terms, each of the parts, sorry, is called a term. So this here is a term, this here is a term, this is a term, and this is a term. So an expression is a collection of all different terms added together. Okay? And you may be able to make an expression simpler by collecting together like terms. So again, if I go back to the apples, in this basket here, I can see I've got 3 apples. So how could I write that? I could write that like 3A. And in this basket here, I've got 2 apples. So I could write that like 2A. Now these are like each other. They're both apples in each basket. So they are like terms. So if I then added 3A and 2A together, what would I get? And it would in fact be 5A. And that would be your final answer. Okay. This one here, again, I've got simplify. If you had to simplify these shopping lists here, using algebra and using letters or using variables, and I'll talk about that word variables a little bit later. We've got Fred's shopping list, Harry's shopping list, and Kelly's shopping list. So if I look at Fred's shopping list, I've got 1 strawberry, 2 strawberries. So I could write 2S. We've only got 1 apple, so I'm going to write 1A. We'll talk about that in a wee second. I've got 1 banana, so I'm going to write 1B. And I've got 1 orange, so I'm going to write 1O. Now that's not wrong, but the way we usually write it, if there's only one of something, one variable or one letter, you don't have to write the 1 in front of it. So all of these ones here, we've got a 1 written in front of them. There's only one of them, so you could write it like 2S plus an A, which is just 1A. You don't have to write the 1 in front of it. Plus B, again, that's one lot of B's, so you only have to write B plus O. Okay, and that's the way we would usually write it. The next shopping list, Harry's shopping list, we've got 2 apples, so how would we write that? 2A, 2 bananas plus 2B, and we've got 2 oranges plus 2O. Okay, and Kelly's shopping list, we've got 3 strawberries, oh sorry, we've got 4 strawberries. So 4 strawberries plus 2 oranges. Okay, and that would be the simplest way you can write it. You cannot add together your strawberries and your oranges. They're different like terms. Okay, let's move on to the next slide. Okay, if I had to simplify these, what would they look like? So I've got questions on this side and I've got the answers here on the right hand side. So if I looked at the first one here, I've got A plus A plus A. So what would that give us? If you look at the right hand side, you should see the answer. And it should be, just a line here. So I can make a line from this to the answer 3A. If I look at the next one now, if I look at this one, oops, sorry, still on lines. If I look at A plus 3A, so I've got, remember what A means? It means one lot of A, so just 1A plus another 3 A's. What does that give you? It would give you 4A. Next one, 3A plus 2A would give you 5A. And then we've got 7A plus 4A, which would give you 11A. And then this one here. So you've got 6A and you're taking away 5 lots of those A's. So how many A's would you have left? And it would be 1A, but how do we write that? We just write it like an A on its own. And then this one here, 9A, take away 2A or subtract 2A, depends what word you like the best. And that would give us 7A. Okay, perfect. So let's move on. Okay. The left-hand side is what Harry eats in a week, and the right-hand side is what Alice eats in a week. So let's just try and simplify that, write it algebraically. So we've got 4 bananas here. So how could I write that? 4 B's plus 1, 2, 3, 4, 5. 5 apples, so 5 A's plus 1, 2, 3, 4, 5, 6, 7, 8. 8 strawberries. So 8 S's. So Harry, that's what he eats in a week. Alice, what does she eat in a week? We've got 1 banana, so how would I write that? You could put the 1 there, but it's best just to write B on its own. And then we've got 3 apples, and we've got 3 strawberries. The next question says, if I collect the like terms, I can simplify the expression. So I'm now asking, what do they have in total? So Harry, what he eats a week, plus what Alice eats in a week, what do they have in total? How can I simplify this? So if I basically add together this expression and this expression, what would I get? So first of all, if I look at the B's, first of all, I see that Harry's got 4 B's and Alice has got 1 B. So how many B's would that give me altogether? And that would be 5B. Next, if I look at the A's, I've got 5A and I've got 3A. That would give me 8 A's. And then I've got 8 S's here and 3 S's here. That would give me 11 S's. Okay, everyone understand? Okay, let's move on. Okay, this is just a little bit of note take if you want to take any notes. Just at the top there, you can read what I wrote there about algebra. So variables, so that's a really important term to learn, or word to learn. So variable is really any letter or symbol that we can use. It's called a variable because it can vary or it can change. So a variable is really any letter in the alphabet. Quite often in maths, we really like to use the letter X, but it can be any letter. So these are called variables because they can change. So X might be equal to 5 in a certain question, but then in another question it might be equal to 6. It can change depending on what the question is. A term is part of an expression. So here it is an example of terms. So 11t, 14h, 7g, 2a, they're all terms. And remember I talked about like terms, so 2a and 3a would be like terms because they're like each other. An expression is a collection of terms. So here is an example of expression because they're a collection of terms. Then I've just wrote like terms like each other, they contain the same letter. And we can simplify an expression by collecting like terms. Okay, let's move on. Okay, so simplify the following expression. Just before we go on any further, I just want to make it really clear about the operations. What I mean about operations and these questions really are your plus and your subtract or your takeaway, depending on what you want to say. Now, when you look in front of a variable or in front of a term, that operation belongs to it. So first of all, if I look at this 3a, there's nothing in front of it, but it means it's positive. Now, you know when you write the number 3 on its own, if it's a positive number, you don't write anything in front of it, but you know it's positive, okay? This one here, if I look at the 4y, that add sign is in front of that 4y, so that add sign belongs to that term. It's stuck to that term. Similar to the other ones, this one here. This takeaway, the subtract, is attached to that x. It belongs to that x. And the last one here, the 3y at the end, that plus sign or that add sign belongs very much to that 3y. And that is very, very important when you're simplifying expressions. So if I wanted to simplify that, you're really looking at these operations in front of the terms. So I've boxed them down here. So I'm going to look at the x's first. So we've got 3x, take away or subtract x. So I've got 3x and I want to take an x away from it. That would give me 2x. And then I'm going to look at the y's. I've got 4y and I'm adding on another 3y. So that would give me 7y. And that would be your expression simplified. Your x's, remember, and your y's cannot add together. They are not like terms. Let's move on. Okay, I just want to write these expressions in a simplified form. So let's go through these quite fast. So I've got 4a plus 8a, which is 12a. I've got 7b, take 2 of those b's away. So if you think about 7b, what that means, it really means a b plus another b plus another b. So there's 7 b's there, 1, 2, 3, 4, 5, 6, 7, yep. And you want to take 2 of those b's. So if you took 2 of those b's away, how many b's would you have left? And it is in fact 5. So your answer is 5b. Next one, you've got a mixture of A, B's and C's. Remember, you can only add together or subtract and take away like terms. So if you want to make it a little bit easier for yourself, you can underline the like terms. So I'll start with the A's. I've got A plus, remember there are adds. That operation is attached to that 5A. So I've got an A add plus 5A, which is 6A. And then if I look at the B's next, there's a B here, 3B, take away or subtract B, that would give me 2B. Now again, that's positive. I know when I teach this, a lot of kids say to me, but what operation is in the middle of these terms? So think about what your answer is. When you say 3b take away b, your answer is 2b. Your answer is positive, so it must be an add or a plus in the middle of it. And then let's look at the C's. C's are here, but there's no more other C's, so nothing happens, nothing changes to that, so it just stays as a plus 2C. And that's your final answer for that one. Okay, let's move on. Okay, my turn to simplify these terms. Again, I'm just going to go through these fast. So 3a plus 5a, 8a. We've got this one here. So we've got 6c plus 7d. This one, 4a. This one, c plus 3d. And again, you can pause this anytime you want if I'm going through it too fast. So once I've done that, you can leave my answers on the screen. You can pause it now since I've done my side, and you can try your side, your turn on the right hand side. But I'm just going to tell you the answers now. So if you want to pause it now. So you've got 4b plus another b, so that'll be 5b. This one here, we've got 10e plus 7f. This one, we've got 8b. Like a common misconception with these questions here is to just take the b away. Remember what 9b means. It means 9 lots of b's. So if you're taking one of those b's away, how many b's have you got left? And you've got 8 b's left. This one here, 5d plus 2e. Okay, we're clear on that. Let's move on. Okay, again, very similar setup. My turn, your turn. Change color of pens. So h is 5, 6, 7y plus 4h, 7a plus 8b, 7k plus 11e, 14y, take away 2b. And then again, now you've got examples here. Pause it now for your turn, but now I'm going to go over them. So 11y plus 8h, 8a plus 12b, 8k plus 7e, and 21y, take away 3b. Okay, let's move on. Again, simplify, same as before. So we've got 8r, take away 5r, take away another r, 2r. Now, sometimes doing it from left to right isn't always the best. Sometimes it's easier to add all the positive things or terms first and then take away the other one. So for example, this one here, I think it would be easier to do 5x, add 3x first in your head. So 5, 6, 7, 8, that gives you 8x, and then take away your 6x, which would give you 2x. Please note here the way I'm writing an x, like just in algebra, not to get confused with the multiplication sign. We usually write an x like this. We've got a little curvy side on it and a little curve on that side to make your x. Okay. Similar with this one, you might want to do 6y, add 9y first, which will give you 15y, and then take away or subtract your 8y. So give you 7y. And again, similar with the last one, so we've got z, add 4z, which gives you 5z, and then take away or subtract your 3z, which gives you 2z. So again, now you've got my examples, you can pause it and do your turn here. I'll just do them quickly now. 7r, 8x, 9y, and 7z. Okay, let's move on. Again, very similar. What I've done in this slide here is I'm going to go into negative numbers. I'm assuming that you are quite secure with your negative numbers. I don't want to dive into how to do it with negative numbers. I'm just assuming that your knowledge of negative numbers is secure. So this part here, so 3x plus x is 4x, and then I take away or subtract a 6x, which would give me negative 2x. This one here, I've got 7t, take away 6t, which would give me 1t, or just t on its own, and then take away another 9t, which would give me negative 8t. Next one, there's different terms in this one, different like terms. So if I look at the m's first, I'll just do a squiggly line under them. Now remember, it's 8m, take away or subtract 6m, which will give you a negative m. And then I've got 2y, take away or subtract 3y, which will give me a negative y. And this one here, I've got 9h, take away or subtract 10h, would give me negative h. And then 11y, take away or subtract 12y, which would give me negative y. Again, pause it now, you've got my examples, and try the ones on the right hand side yourself. I'll just write in the answers now. Negative 3x, negative 8t. No, it's not. Oh, sorry, now deleted this. Sorry guys, just managed to make a little mistake there, and then when I tried to rub it out, I deleted everything. So I've just wrote everything back in again. Even as maths teachers make mistakes sometimes. So there's all the answers for this one. Let's move on. Okay, again, talking about your negative numbers here. So if you're on 3x and you take another 6x away, you'd be on negative 9x. If you're on 8h, take another 5h away, you'll be on negative 13h. Let me just write in these answers. This one here, so we've got negative 4m, and then negative 9m. Okay guys, again, I've just written in the answers for the right hand side for your turn. Let's move on. Okay. Now this is something that sometimes confuses kids. So I've talked about like terms. So b is a variable. B squared is a very different variable, so it's not the same. It is not a like term to b. Even though it's got a b in it, it's got b squared, which means b multiplied by b. And again, b cubed, which means b multiplied by b multiplied by b, is not the same as b squared. So they are not like terms. They cannot be added together. They cannot be subtracted. They are not like terms. So b squared and b cubed are different, cannot be added together. So if I had an expression like the one below, how would I simplify it? So if I look at the b's first, I've got 6b here, and I've got an add b here. So that would give me 7b. And then if I look at the b squareds, I've got a positive b squared here. So b squared add another 2b squared. That would give me 3 lots of b squared. Nothing changes with those powers. The indices here do not change. It's just how many of the b squares do you have. Similar to the b cubes. So you've got 2b cubed, add 5b cubed. How many b cubes do I have altogether? And it would be 7b cubed. that would be the final answer here. That would be the final answer to this question. You cannot add b's, b squares, and b cubes together. Okay, thank you. Let's move on. Okay, a little reminder just about addition pyramids. So all you're going to do is you're going to add the two numbers below the brick or below the box. So you want to add your 6 and your 11 together to get the answer in here. Okay, so 6 add 11 is 17, so 17 will be the answer in here. To get the answer in this little brick or this little box in here, you would add your 11 and your 2 together, which will give you 13. And then to get the final answer, the top one here, you're going to add your 17 and your 13 together to get 13. Okay, just a wee reminder, because as maths teachers like to give you addition pyramids involving algebra. So if we move on to the next one, very similar. Again, still addition pyramids, but if I had an unknown in here, plus 5, how would I get to the answer 17? And the answer in here must be 12. Okay, then 5 adds 9 is 14. And how to get the top box here? You're just going to add your 17 and your 14 together, so you get 31. Okay, so we're just going to do the same sort of thinking, but we're going to introduce some variables. So here we go, my turn on the left hand side. So if I point a little pointer here, so I'm looking here, I've got n plus 2n, so what would be in this box here? And it would be 3n. So what would be in this box here? So I need to do 2n plus n plus 2. So that would give me 3n plus 2. And then what would be in my top box here? It would be 6n plus 2. Next one on my turn, on the left hand side on my turn still. So I'm going to add your 3x plus 1 plus your 2x plus 6. Just treat your numbers like you would like terms. So your x's are like each other, so you're going to add them together. And your numbers are like each other, so you're going to add them together. So we've got your 3x and your 2x. What does that give you when they've added together? It gives you 5x. And then you've got 1 add 6, which gives you 7. And then go into the next box. Oops. Just clear this part. And we've got 2x plus 6, add x, take away or subtract 1. So 2x plus x is 3x. And then we've got 6, take away 1 or subtract 1, which is 5. Now the answer is 5, which is a positive 5. So let's add 5. And then the top box is going to be 8x plus 12. Okay. Please pause now to do the right hand side yourself. I'm just going to fill in the answers now. That's me filled in the answers for your turn on your right hand side, so just check that you've got them right. We'll clear it now and let's move on. Okay, really now I've just made lots of examples here. So I've done easy ones, medium ones and hard ones. Be very careful with that last column there. You really have to be confident with your negative numbers. I will flash up the answers at the very end. So one more slide to do, then we flash up the answers for this. So just pause it now and try it on your own. Thank you. And then really just to end, I want you again to pause this video now and just take a few minutes, 2 minutes I've said, to write down as many equivalent expressions as this here. So I'll do a few for you, but please pause the video now. Think about it now. You could start really easy. So if you want to get an expression that is the same as 5x plus 2y. So it could be an x plus another x plus another x plus another x, which is 5x plus a y plus a y. That is the exact same as 5x plus 2y. Or you could start with a 6x plus 9y, take away x, take away 7y. Again, once that expression is simplified, it gives you 5x plus 2y. So you get the idea. So please just take 2 minutes just to try and get your head around that, all right? And the next slide is just going to be the answers to the previous slide. So if you've not finished, don't watch it yet. So I'm about to flick on to the next slide. And that's us finished, Julie. So here you go. Here's the answers for the easy, medium, and hard questions I put up earlier. And that's us. Thanks for watching, guys. See you soon. Bye now.